Hello everyone, welcome to my YouTube channel, and in this video I will update my part for the organism part for the paper. And first, so this paper is also as a particle pass, and we call it a realistic organism for Dylan constrained scattering in the cloud environment. And so we will use example using the ICPC paper. So here is the basic structure of the workflow. So it's a general workflow structure, and this is the building set. This is the attribute for the cloud computing environment. So the building period is 10, and the cost for each time interval is 5 for the farthest, and the second one is for 2, and the cheapest one is 1. So this is a execution time for different tasks in different virtual machines. So we'll use this kind of parameter to do. But how we do it? So we can go to the organism part. So first we need to add a the entry task and the access task to their each dependence into the workflow graph. And we mark the T entry and T exit as clustered. Then we compute the priority value for each task. Then we compute the last finish time and earliest finish time for each task. Then we cluster the graph G based on the priority value for each task, workflow task dependency. Okay, but how we can calculate the priority value? We use upward priority value, which is calculated based on the average task execution time and the longest path from the access node, which is traversed from the access node, and with this kind of formula. So the TT is data transfer time between each task, and the P is the priority of value for the successor. So for this stuff, and we just use an example to calculate the upward priority value. So it's here, and then we follow this algorithm to find all the critical passes. Then it's start from the first task to the end task, and we select the first unclustered task having the highest priority value and mark this task as clustered. Then we do a deep search until a success which is clustered already. So the first is we start from the T2, then we go to the T6. Oh, sorry, it's 59. We go to T6, and then we go to T9. So this is the first critical path, and second is T3, and the third is T1, T4, T7, and the last one is T2 to T8. So this is all the critical passes. And then so the second part is just the scheduling the passes into the different virtual machine. So as we can know here that the path founded is the same with ICPCP. So we just use the ICPCP method to do this kind of scheduling. This is the provision part for the ICPCP. But we found the data transfer time from T3 to T6 in the first instance of virtual machine 3, tab 3. So the author didn't consider the data transfer time. So we need to add in the data transfer time of sending and receiving time to the current billing cycle, which means that if the task, so we need to extend the billing period for the data sending time for the current billing period if it doesn't have the task running in the same virtual machine. So actually the billing period for the task 3 in the virtual machine tab 3, it should be start from 0 to 11 instead of 0 to 9. But actually, so this is just using another billing cycle for the virtual machine 3, and the way to make the computing more robust, and we just use the virtual machine tab 2. So here we have this kind of provisioning. So we will change this virtual machine to tab 2, and we use the virtual machine. We use the third virtual machine of tab 2. Yeah, it starts from 0 and into 5. So we will extend by adding the 2 time period of the data sending time. Also, for the receiving part, we also have this. We also need to start the virtual machine before when the T2 is start from sending its output to T5. So right now the billing model is more realistic than previous one. But we can also see here that this the T3, T5, T8 can be scheduled into one virtual machine without cost increase, and also it's more robust since so we can use the super virtual machine to instead of using 4 virtual machines. So this advantage. So this is just a small contribution. Yes, but right now I don't have any good idea to make the contribution much more. So yesterday Dr. Liu asked me to add the provenance. So and also we have the paper. We have one paper talk about the provenance, and also maybe this is a good selection. So I think I will follow these steps and to add the province part used in the provisioning. So that's it. Thank you.